Yes, sir. Just a minute. Yes, sir. Are you able to see my screen?
Yeah.
Yes, sir. You said to reduce the mesh size actually in this.
No, did you identify the loading conditions, everything for this?
Loads. No, sir. I just made two these.
Okay, show me what is the error that you are getting and then show me that one. Check completed, it is right. There is no errors.
Warning.
No, that is a warnings only. So you don't worry about the warnings.
Okay.
Okay, so no errors, right? So I thought it was an error. Check. Okay, fine, no
So
issues.
whatever be the warning, we don't.
Whatever be the warning, you can neglect that. No issues on that.
Okay. So
But that is giving you information that the mesh is not so good, not so great. But it is trying to solve the problem, but the mesh is not so great. That's what the information it's giving.
Okay. Sir, in this column now, we have what we have to do is we have to make it a uniaxial loading column. And then go for the static analysis of it.
Okay, what is the load value?
Anything, sir, anything of our choice, suppose 10 Newton, 20 Newton, anything, whichever.
It's a tensile load or a compressor load?
Compressive loads, uniaxial compressive.
You are talking uniaxial tensile test, right? But again, it's a tensile load or a compressor load. That's why I want to confirm.
Compressive, sir, compressive load.
Compressive load only. Okay, so one end that you have to fix it. So try to fix it at one end. You have fixed it. Show me the material properties first, what you have applied. Density 7.85. Okay. Plastic data is 250. These are like true stress and true strain values only, right?
Yes, sir.
Okay, fine then. Fine. Okay. Yeah. Now go to your step module. Step module. Yeah. Click on that. So we are going for time period as a 1 increment. Click on increment, not 0.1 and 100. Okay. You can start from 0.01 also, because this is like, what is the size of this beam?
Sir, it is ISMB 400.
Okay, fine. Okay, 0.01 you can keep. If it is not necessary, then immediately it will trim that automatically. Okay, no issues. Yeah. And go to boundary conditions, that is the load module.
Yes, sir.
The boundary conditions that you have given. Encaster, so that side that you are fixing up all the things. Can you zoom that region where you are fixing?
So both the sides
Both the sides. Then how come it will be like tensile things? One side you have to apply this compressive load, right?
Yes, sir.
It's a uniaxial test or like a simply supported beam. Now whatever you made is simply
Sir, it is a column actually. Actually, it's a column, so it needs to be fixed from both the sides, no?
Then it should be like a simply supported beam. And where the load is coming?
From this side.
How come it will be? when if it is fixed, how come the load should come on the top side, right?
Yes, from this side you're saying.
Yeah. Can you give me the control? See, either the load. Why I'm unable to control this? Yeah, I think now it's coming. Oh God. The load is coming on this.
Sir, actually it's a column, so it will come from the top of that. No?
Top is this only, right? How
Not
it is
this side.
placing, how it is placing, that's what it is important.
Vertically, sir. Actually, this is horizontal. It will be placed vertically. No? Yes. On this plane, I guess the load will be coming.
On this plane, the load is coming.
Yes, sir.
Okay, so you have to fix only this one, not this.
Okay, both ends we don't have to fix.
Yeah, both ends you know. Why you are fixing in the middle also?
Middle. I just selected the whole plane, this plane.
Okay.
I got selected everything.
Just to make sure this, I'm just avoiding all of that. So let's go this. Now go to create underscore bottom. I'm just calling this as a fix underscore bottom. Continue. I'm selecting that surface to be a fixed. So I can just give done. So now when I just go create a boundary conditions, I can say it's a fix underscore bottom. Symmetry conditions. Go to search over here. Fix bottom. You can select this, highlight, and continue. That's it.
So this will be fixed.
Yeah.
Now it will be a beam, na? Like a railway track. It will be.
Oh, this view is like this. No, I could not able to control this properly. Now tell me that where exactly that you want to apply the load over here or you want to apply the load on this?
Yes, sir. Yes, on this.
On this. Okay, fine. So
So the fixed end should be different, no? Na?
yeah, fixed end should be a different. Now this should be a fixed end.
Yes, sir.
So go to tools, set, edit, and fix bottom. Yes, this is the one that I want to fix. Okay.
Yes, sir.
Okay. So now once that you got fixed it, I can just so go to tools, set, create. Loading. How about like others are so not serious about this? This Omnesh.
Don't know about them.
So I'm just giving done. So now actually the loading it has been done. So I can just go here. Sorry. This is a surface, right? So you can apply, if you want to apply this pressure load, that you have to apply it, or you have only a concentrated force with you.
Concentrated force.
Oh no, what is the value that you have? You have like in terms of like Newton per mm square, or you
Sir,
have
sir,
Newtons?
anything, whichever we can go for this experimental.
Okay, fine. So let's say I'll show you both the things also. Let's say that if you are going for a pressure, so you can just go.
Sir, uniaxial loading will be, I guess, the concentrated force only. So we should go with concentrated force.
One second. Sorry. So if it is like a concentrated force, it's a point load. So point load, anyways, that you are applying to this entire pressure. So what you have to do is, you can do one thing. You can just go here and between this to this, you can create a new point. Okay.
Yes, sir.
New point, you got created it. Now go to interaction module and click on this RP and click on this new reference point that you have created it and go to couplings. So that's where like compressive load you can say, and then you can go to its coupling or coupling. So master is compressive load point. So we can say it's a compressive load point. I can select that as my compressive load point. So done. And then the surface is the slave surface. I need to select this, and this is my surface. You can say it is like surface underscore slave. So these two I'm just connecting with as a kinematic coupling. Choose surface, edit, slave surface. So this is entire surface, it is there. If you see both the connections to only one side also, but this is an entire surface, it got selected. Okay, that's the other thing is just a visual problem. Okay, so now you can just go to your load, and in the load that you can choose your compress. Sorry, you have to go for the load, right? So you can just go with some compressive load, concentrated force you can choose, and you can choose go to the sets, and you can choose this is compressive load point, and to this compressive load point, in which directions that you are trying to apply the load now.
For the direction.
This direction.
So is it Z?
Z direction. Okay. So
negative, it will be negative of Z, no?
yeah. So these two are like 0 and 0. And now I just need to apply in negative directions. Let's say I would like to apply something like around some 10 newtons of a load. Okay, roughly I'm just giving you the value of 10. Okay, slowly we can start increasing that. I'm just giving okay. Now once if you just give okay, here this is what the load direction, you can see the point, right?
Yes, sir.
Okay, so now you can save your model. I don't know that where you are saving it. This is where you are saving it. GAB IMSB 400 CE. Okay.
Yes, sir.
And then I would like to go for data check once again. But why you're deviating your problem to this one?
No, sir, this is the one given by my guide.
Your guide is giving this to you that you have practiced it well or not to confirm that. Navin is giving it to you.
Yes, sir, yes, sir. So job completed successfully.
Okay, so now right click on this and you can hit for continue. So it will ask you to override things. Okay, no problem. You can click on OK to override it.
Some errors are there.
Right click on this. Monitor. Okay. So too many attempts to make this particular increment and saying that. Okay, so let me go into this load. Load value instead of let's give this as 100 and we will see this.
Successful.
So all those are like unstable steps that is coming up. So the problem is not get stabilizing. So let me dive into this. This is fine. The solution appears to be a diverging convergence in too many attempts to make this particular increment. Convergence checks for equilibrium iterations. Force equilibrium is not achieved.
So again, some error is there.
Yeah, I'm seeing that. Convergence checks for the equilibrium iteration. Okay. Sweet cover. There is something wrong here. A. See.
So why is it saying too many attempts are being made?
It's unable to start the problem. I don't know the reason. I just need to check the model from the beginning.
Now it has run successfully, no?
No, not yet.
Not yet.
Yeah. What is your machine configuration?
So my system configuration,
Yeah.
sir, it's 7 Gen i5 and 8 GB of RAM and 2 GB NVIDIA graphic card.
Okay, but still it is very slow, it seems. Must move the load, yeah. Geometry you have made here or like you brought it somewhere?
No, sir, I've made in this only.
Why you have not fixed this one? Maintain properly.
Right, sir.
This is like this. This end is like this, and this end is like this. Geometry.
Sir, is it due to this it is not happening?
Yeah, because element distortion is failing, and because of that, like it's causing an error. But first thing is like geometry is not correct. Why this
Bottom
points
part
are
is okay.
okay? This is a radius points. Okay.
Yes, sir. Previous one.
Can you able to see open that monitor window, because I can't see the bottom icons on your screen. Yeah. Oh my God, it's going away. Why?
Sir,
Can you show me this bottom icons once?
which one, sir?
Bottom icons will come, right? It's hiding for me. Go to monitor, Vadan, and then open that one.
Bottom icons.
Monitor will be there automatically. You can just check that.
Are there any more icons, sir?
Go to monitor window. like this abacus, two abacuses are there. Another third window is there, right? You can open that window. Yeah. Yes. Oh, there is something wrong with the geometry itself.
So just due to geometry only, this bonding is coming out, no?
Yeah, one thing because of the geometry, this warning is coming, and the other thing is also like why this,
Other error is on what basis is it come?
I'm not getting control. Okay, I got. We'll do one thing. We'll do one thing. One second. Send me that CAE file, either in the chat window or in the WhatsApp.
Currently it is open, it can be shared.
Yeah, no problem. You can save it once and then share it.
Should I save this?
Yes.
Should I save?
Yeah,
Save.
and then give me that CAE file. Yeah, that one. Let's copy that and give it. No need to save that again. So you can directly drop me in there from drag and drop them. Drag and drop me in the chat window.
So it's not, it's currently in use.
Okay, you can close that and then show me that. I'm just stopping your sharing.
Is it there?
Yeah. Yeah, I'm sharing my screen. You can see my screen, right?
Not yet. Yes, now. Sir.
Yeah, okay. I think I have a better control on this. It is 343 kgs. That's correct. Hello.
Yes, sir. Yes, sir.
Distance is 140.
Yes, sir.
Height is 400.
Which height, sir?
This height is 400.
Total?
And then the length is 6,000.
Yes.
Okay, fine. What is the load you said?
Load, sir, you have put 100 kilonewton. No, sir.
Okay,
100
fine. Yeah. Now it will solve. For sure, it should solve. Okay, it's more than 10%, it's solved it. So solution will stabilize automatically now.
How much time it takes for analysis?
It's already 30% is done. Another 5 minutes, maybe max. Now, it's got completed successfully. But I just need to check the animation now. But because of this, actually, it's quite bending also, it's happening, right?
Yes.
You are not preferring this particular bending also, right? True, or you are allowed to do that?
It's just an experimental step. So
Okay.
to know what's
So
happening.
remember this as a one step, and later on that if you just want it again, yeah. First, let me confirm that what is the load value that we got. Just want to go and measure this reaction forces. So the reaction force is coming around 68,479 newtons because everything is in mm, right?
Yes,
So,
sir.
but that much it is not required, right? What is the newtons that you want?
Sir,
How many
what
newtons that you have?
reaction requirement?
Sorry?
So what did you say? What the outcome that outcome I require?
Sorry?
So what did you say?
No, what is your requirement? How much amount of a load that you want to apply on this?
In this just that we have applied 5 Newton. No?
5?
At
It
that
is not
time,
5 newtons actually. So that's what I just want to explain you. See, when we are going to apply this particular load that we were getting some failures and we have noticed that, right? So that's why
yes.
I want to apply it as a displacement. So I'm just trying to apply this particular displacement of -5 and then I'm measuring the force to the outside. Okay. So the force that what I got is like 68,000 newtons of a force I got it. Now I'm just arresting all those degrees of freedom, everything. Even like I don't want to see any kind of rotations also. Now let me check on this, how whether the problem will respond for this. F equal to kx, right? So when I'm trying to solve for the force, when I'm getting an error, so I will solve for the displacement. I will feed the displacement and solve for the force. So vice versa, I can able to calculate that. So when I'm facing an errors with the force, I'm trying to apply the displacement now. That's it. Even in your problem also, you can try to apply the displacements and eliminate the forces, then it should solve automatically.
Okay, sir.
So it's still more like still more getting stabilized it, and it is solving so quickly also now after fixing all the other degrees of freedom. So that is what like I have to understand your application, and then only I can able to say whether the remaining degrees of freedom has to be arrested or not. So those kind of decisions I can take. So now, once if you just see this. Okay, so this is what is the stress that you can see that. If you want, like I can increase the size to some 50. Okay, so this is how actually it is coming. So quick things that what you have to confirm is from your professor or like who has given your work, that while loading this particular point, whether the remaining degrees of freedom is free or it has to be get arrested. So you can cross check with them. If I know the application, then I can able to comment on that, but I don't know your application, so that's why I'm not commenting anything on this. You can leave them, so there is no issues. Or if you want to arrest them, you can arrest them also. Either way, that whatever the way that you want it, we can able to do that, and you can able to apply this loading everything. So just give okay. Confirm that. Here we are not applying the loads. We are applying this displacements to the reference point that we are applying it. Once the displacement is applied, you just go to your results over here, and in the results, instead of a stress, you can check your reaction forces. So this is what is your reaction force that you are getting for 5 mm displacement. And again, that if you want to plot for a graph, so create an XY data, ODB output file, continue. And here you have to select this as a unique nodal. And here you have to select this reaction force as a magnitude. Go to element nodals, node labels, node sets. Node sets as compressive load point. You can select that one and you can plot that one. So this is how as the displacement. So this is what actually the Newton-Raphson time actually. So it's a 1:5. That means 0.5 here it is means 2.5 mm it is displayed. Okay, 1 here it is 5 mm displacement it got applied it. So for 2.5 mm of displacement compressive load it is coming. This is what the load value. It is 1 e power minus 6. So that is around something around 0.6 or 0.7 e to the power of. If you want this data also, you can just go here manager and you can just click on this edit. Then you can get this particular data and you can copy this data into your Excel sheet. Got me?
Yes, sir. Tomorrow at what time should I contact you?
Tomorrow 3:30 to 4 I'm blocked, and in the morning same time I think around at evening 5 o'clock only.
Okay, so actually I have to discuss my part now, because and that the video, yes sir, video I was asking that which that partition was created, you haven't uploaded it. I was searching in my channel.
Okay, fine. First you do one thing. You create this, try to get this particular curve and send me that image. Like while creating that, if you got any doubts also, I'll help you out on that. Okay. So now we have a time for just.
Can you send me this file, this one, whichever?
Yeah, I can do this. One second. The CAE file. Where is that CAE file? This is fine because we are working, both are working with the same version, right? This IO error, what is that? How come?
Huh?
This IO error it is coming. Why it is like that? You are drag and drop only, right there?
Yes, sir.
Why this IO? Okay, maybe because it's open.
Yes, sir. When it's
Yeah,
open, it's
now
not getting shared.
it's 3.17 MB it is there. You can use that. Okay.
Yes.
So you got this one. So start using that. And let me know, like I will be on front of machine till like 8 o'clock. So you can call me at any time, okay?
Okay. From tomorrow from same time, no, sir?
Tomorrow mostly at 5 o'clock. Some 15 minutes before or after.
Also, sir, tomorrow, yeah. Can we model whole dummy section of whatever my project is, one product, so I can replicate everything of that with whatever my data is.
Whatever you
Also,
want. You can just come up with all the information tomorrow. I'll help you out on that, okay?
I also have data of some cyclic loading also. You said me to collect the data for that.
Yes,
I've got
yes.
that data.
Okay, fine.
So
Yeah.
once you can check the data, sir, whether it
Sorry.
will be usable or not. Once, can I show you the data?
Yeah, sure. Show me that. I'll stop sharing it. Yeah.
Is my screen visible? So this will be fine now for cyclic loading.
Yes.
It is
Yeah.
displacement versus time.
Okay, fine. Yeah, that's good. No problem. Yeah.
Okay, sir. Thank you, sir.
Okay. Yeah. Okay, that's all right.
Yes, sir. Yes, sir.
Okay. Yeah. See you. I'll upload the videos also now. I'll correct that code and then I'll upload that. Okay.
Thank you, sir.
Okay. Thank you.